Hi everyone, so this is my math basics, fractions made easy, and the first thing I want to talk about is equivalent fractions. So equivalent fractions are fractions that look different, but they have the same value. So for example, we have 1/2 is the same as 2/4, which is the same as 4/8, and they have the same value because we can see that they both occupy half of the circle, but they just have slightly different appearances. So they have a different number of slices, but they hold the same value. So how do you get equivalent fractions? So you can get an equivalent fraction by multiplying or dividing the numerator and denominator by the same whole number. And you need to make sure that both the numerator and the denominator always have whole numbers in them. So for example, 1/2, if you multiply both the numerator and denominator by 2, you can get 2/4. And if you multiply both the numerator and denominator by 2 again, you can get 4/8. And we can also convert 4/8 back to 2/4 by dividing both the numerator and the denominator by 2. And we can convert 2/4 back to 1/2, essentially reducing it by dividing both the numerator and the denominator by 2. So when you do this, essentially what you're doing is multiplying by 1, and that is why the value doesn't change. So what we're doing when we're multiplying 1/2 by 2 in both the numerator and the denominator is we're multiplying by 2/2. And if you remember, any number divided by itself is 1. So 2/2 is the same thing as 1. So what we're doing is multiplying 1/2 by 1, but we're changing the appearance of that 1. And that is why the appearance of our product changes as well. And same thing when we divide by 2 in both the numerator and the denominator. That's the same thing as multiplying the numerator by 1/2 and the denominator by 1/2. Um, and 1/2 divided by 1/2 is 1. So we'll talk a little bit more about that when we talk about dividing fractions. And we can use this trick to reduce fractions. And so when you reduce a fraction, you're writing it in its most simple form. So a fraction is fully reduced when there is no number that both the numerator and the denominator can be divided by to produce an equivalent fraction with a smaller numerator and denominator. So for example, we have 16/20. This is our original fraction. And if we divide both the numerator and the denominator by 2, and we can recognize we can do this because they're both even numbers, and even numbers can always be divided by 2. So that's just a little hack. But if we divide the numerator and the denominator by 2, we get 8/10. Now that's a reduced version of the original because the numerator and the denominator are smaller than they used to be. But this is not fully reduced because we see that we still have even numbers on both the numerator and the denominator. So we know it can be reduced again by dividing them both by 2. Once we do that, we get 4/5. We know this is fully reduced because there is no other number that we can divide 4 and 5 by to get whole numbers that are smaller on both the numerator and the denominator. Because if we divide by 2, we get 2/2.5, and that is not a whole number in the denominator. And that is true for any number of 2 or greater. It will always have some sort of decimal involved, unless you're dividing by 1, but that keeps the fraction the same. So that's not reducing it any further. So that's how we know we fully reduced our fraction. Now I want to talk a bit about multiplying fractions. So when you multiply fractions, you need to multiply the numerators with each other and the denominators with each other. So 3/4 times 1/6 would be the same as 3 times 1 divided by 4 times 6. So that would be 3/24. And both the numerator and the denominators are divisible by 3. So once we do that, we get 1/8, and that's our fully reduced form. Now, just a bit of a hack. It doesn't matter which order you multiply the numerators and the denominators. So this allows you to reduce along the way. So what do I mean by that? So you know how we did 3 over 4 times 1 over 6, and that gave us 3 times 1 over 4 times 6, which gave us 3 over 24, which gave us 1 over 8. Now let's say we had 3 over 6 times 1 over 4, so we just swapped the denominators around. 3 over 6 reduces to 1/2. So we can actually reduce that right away. So if you look down below, we have 1/2 now times 1 over 4. And right away, we can do 1 times 1 is 1, and 2 times 4 is 8. And that's how we can get 1 over 8 quickly. So what you can do is by looking at the fraction, you can quickly see what you can cancel out. So what do I mean by that? If we look here, we see 3 over 6. 3 and 6 are both divisible by 3. So right away, we can do 3 divided by 3 is 1, 6 divided by 3 is 2, and right away we get 1 times 1 over 2 times 4. You can also do that with the above fraction. 3 is divisible by 3, so that gives us 1, and 6 is divisible by 3, so that gives us 2. And then right away, 1 times 1 over 4 times 2. And then we don't have to go through the trouble of finding the greatest common factor, etc., to reduce. So just a few practice problems now. So let's go through them together. So 3 over 8 times 2 over 3. So right away, we can see there's a 3 in the numerator and a 3 in the denominator. So those are both divisible by 3. So they can go to 1 right away. And now we have 1 times 2 over 8 times 1. So that's just going to be 2 over 8. And right away, we can notice that they're both even numbers, so they're both divisible by 2. So then we get 1 over 4. And if you notice that right away here, that's great. You can divide them by 2 right away. Now in the second one, 16 over 9 times 1 over 2. So 16 and 2 are both divisible by 2. So right away you can divide them by 2 to get 8 and 1. So now we have 8 times 1 over 9 times 1. So that's just 8 over 9. For the third one, we have 5 over 4 times 3 over 25. So 5 and 25 are both divisible by 5. So right away, we can divide them by 5. And now we have 1 times 3 over 4 times 5. So that's just going to be 3 over 20. And lastly, we have 2 over 3 times 9 over 7 times 14 over 6. So that's a big one. But let's go through it together. So right off the bat, we can see we have a 2 on the top and a 6 on the bottom. So these are both even numbers that are divisible by 2. So we can reduce those right away. So 2 divided by 2 is 1. 6 divided by 2 is 3. Okay. 9 on the top, 3 at the bottom. Both are divisible by 3. So we can do that as well. So 9 divided by 3 is 3. 3 divided by 3 is 1. Now, is there anything further we can reduce? We have a 3 and a 14 on the top, and a 7 and a 3 at the bottom. So if you'll notice, 14 and 7, they're both divisible by 7. So we can do that as well. So 14 divided by 7 is 2. 7 divided by 7 is 1. So now what we're left with is 3 times 2 over 1 times 3. 3 is divisible by 3, so those go to 1. And this is a bit messy now, but if you'll notice, we have 1 over 1, 1 over 1, and 2 over 1. So our answer is simply 2. So that's how we can turn something very messy into something very neat. Now let's talk about dividing fractions. So when you divide fractions, all you're doing is multiplying the dividend, which is the number that you're dividing, by the reciprocal of the divisor. So a reciprocal is just when you swap the numerator and the denominator, and the divisor is the number you're dividing by, or the number of groups you're dividing into. So for example, we have 1 over 4 divided by 3 over 4. So 1 over 4 in this case is the dividend, 3 over 4 is the divisor. And so to do this, all you have to do is flip the divisor and multiply. So that's going to be the same as 1 over 4 times 4 over 3. So notice the 3 over 4 just flipped to 4 over 3. And then we multiply as per usual. So 1 times 4 over 4 times 3. And that gives us 1 over 3. So it's very simple. No need to worry. So let's do a few practice problems. So we have 3 over 8 divided by 3 over 2. So all we have to do is flip this around and multiply. So that's going to be the same thing as 3 over 8 times 2 over 3. These go to 1. And then we're left with, and these are also divisible by 2. So that goes there. And we're left with 1 over 4. So let's do the second one now. 16 over 9 divided by 4. So you don't see a denominator here, but it's actually 1 because any number divided by 1 is itself. So we can just rewrite it like that, and then we can flip it around and multiply. So that's going to be the same thing as 16 over 9 times 1 over 4. 16 and 4 are both divisible by 4, and that goes to 1. So what we're left with is 4 over 9. Now for the third one, we have 5 over 4 divided by 15 over 2. So that's going to be the same as 5 over 4 times 2 over 15. 15 and 5 are both divisible by 5. And 2 and 4 are both divisible by 2. And so what we're left with is 1 times 1 over 2 times 3. So that's going to be 1 over 6. And lastly, we have another big problem, so try to attempt this on your own before looking at my solution. So we have 2 over 3 times 9 over 7 divided by 1 over 6. So let's make this all multiplication. So let's keep the first part the same, times 9 over 7. And let's convert 1 over 6 into multiplying by 6 over 1. Okay, now let's just reduce and then multiply. So right away we can see that we have a 6 and we have a 3. So 6 and 3 are both divisible by 3. So 6 divided by 3 is 2, and 3 divided by 3 is 1. And now I don't see any other things that I'm able to reduce right now. So let's just go ahead and multiply. So we have 2 times 2 times 9. So 2 times 2 is 4. 4 times 9 is 36. And we have 36 over 7. So that would be our final answer. Now let's talk about cross multiplication. So cross multiplication allows you to generate an equivalent fraction with a specific numerator or denominator, and this is good for comparing ratios. So to do this, you multiply diagonal corners with each other and set their product to equal one another. Then you can solve for the unknown value. So for example, we have 3 over 4 equals x over 8. So we want an equivalent fraction with a denominator of 8. So to do that, we're going to multiply the 3 and the 8 and set that to equal 4 times x. So we have 3 times 8 is equal to 4 times x. And so now to get x, we have to divide both sides by 4. So x is equal to 3 times 8 over 4. And right away we can see that 8 and 4 are both divisible by 4. So 4 divided by 4 is 1, and 8 divided by 4 is 2. So x is equal to 3 times 2 divided by 1, or 6. And so that's how you can do that. Now I just want to share a little bit of a hack. That's not really much of a hack, but it allows you to do things quicker. So a quicker way to cross multiply is to just multiply the two known values that are diagonal to each other and divide by the remaining known value. So using the same example, we have 3 over 4 is equal to x over 8. So all we're going to do is multiply the two diagonal known values, so the 3 and the 8, and then divide by the remaining known value, so the 4. So x is going to be equal to 3 times 8 over 4, or 6. And so that's just how you can do that a little bit quicker. So now I want to give a bit of a practical example of how you would use cross multiplication. So I said cross multiplication is good for comparing things like ratios or finding an equivalent ratio. So let's say we have 3 cookies for $8 and we want to figure out how much 5 cookies would cost. So remember, we're finding an equivalent fraction. So what we're doing is we're keeping the value the same. So the cost per cookie is going to be the same, but we just want to show it in a different way. So we're showing it for 5 cookies versus 3 cookies. And you could also do this for 10 cookies, for 100 cookies, etc. So let's do this using cross multiplication. So remember I said you can multiply the two opposite known values and divide by the remaining known value. So to figure out the cost for 5 cookies, we do x is equal to $8. Remember to always put your units. So $8 times 5 cookies divided by 3 cookies. So the cookies cancel out, the units cancel out, and we are left with $8 times 5 divided by 3. So that's going to be 40 divided by $3. And we can't have a fraction of dollars, so we're going to round that to the nearest penny. So we get $13.33 for 5 cookies. So remember, this would be in place of that x, so 5 cookies would be $13.33. And then I just put a therefore statement. So that's what those 3 dots mean in the symbol of sort of like in a triangular shape. So therefore, 5 cookies would cost $13.33. And now I'm just going to give one more example of how we would use cross multiplication to solve a real world problem. So let's say we have 3 brands of cookies. We have cookie box A for $16 for 10 cookies, cookie box B, which is $9 for 7 cookies, and cookie box C, which is $19 for 17 cookies. So that's a lot of cookies. And we want to figure out what the best deal is. So what we can do is find the cost per cookie for each cookie box, and the one with the lowest cost per cookie is going to be the best deal. So if we look at box A, it's $16 for 10 cookies. So that's going to be how many dollars for one cookie? And we're going to set up this kind of equation for all the cookie boxes. And then we're going to solve for x. So remember, you're multiplying the two opposite known values. So we know one cookie, we know $16. What we don't know is this x. So we're multiplying the two opposite known values and dividing by the remaining known value. So that's how we get this equation here. So x is equal to $16 times one cookie divided by 10 cookies. So remember, those cookie values cancel out, and we're left with $16 times 1 divided by 10. And that gives us $1.60 per cookie. Now do the same thing for box B and do the same thing for box C. And we're left with about $1.60 per cookie for box A, $1.29 per cookie for box B, and $1.12 per cookie for box C. So obviously box C is the cheapest per cookie. So therefore, cookie box C is the best deal because it has the lowest cost per cookie of the 3 boxes at only $1.12 per cookie. So always try to include a therefore statement at the when you're done solving your problem. It just summarizes everything and makes it very clear what your answer is, and try to be as descriptive as possible. Now I want to talk about adding and subtracting fractions. So when you're adding and subtracting fractions, it's a bit different from multiplication and division, in the sense that you need the denominator to be the same for all the fractions that you're adding or subtracting. in order to add and subtract them. So, for example, we have two pies. We have a quarter of one and 3/8 of the other. If I ask you to add these two together, it's a bit difficult because the slices are different sizes. So you don't really know what the answer to that is. But if we make the denominators the same, so we have um, everything divided into eighths for both the pies, it's a lot easier because now we have 2 of the 8 slices plus 3 of the 8 slices. So we have a total of 5 out of the 8 slices. So do you see how it's easier to add once everything is the same size or has the same denominator? And similarly for subtraction, if you had half of the pie and I asked you to subtract 1/6 of the pie, it's a bit difficult because they're different sizes, so you don't know what number to write. But if I converted that 1/2 to 3/6 so that they have the same denominator, it's a bit easier because now we can see that we have 3 out of the 6 slices and we're subtracting 1 out of the 6 slices. So now we're only left with 2 out of the original 6 slices, and it's easier to write that way. Yes, we could reduce that fraction further by dividing both the numerator and the denominator by 2 to give us 1/3. And that would be the same thing, right? So how do you get the same denominator? So to get the same denominator, you need to look for the lowest number that is exactly divisible by all the denominators in the equation. And then that would be considered the lowest common denominator. So you want the lowest number that's exactly divisible. And what do I mean by that? I mean, once you divide it, you get a whole number. You don't get any decimals or any fractions. So for example, if we want to add 1/3 and 1/4 together, what we do is we look for the multiples of 3 and 4, and we find the lowest one that they have in common. So the multiples of 3 are 3, 6, 9, 12, 15, etc. And the multiples of 4 are 4, 8, 12, 16, etc. Right? So the lowest one that they have in common would be 12. So now we need to make equivalent fractions like we did earlier, but we want the denominator to be 12. So we need to multiply the numerator and the denominator by the same number. So we're essentially multiplying by 1. So that doesn't change the value, but it changes that appearance. So if we look down here, we have 1/3 and we want it to have a 12 at the bottom. So we want an equivalent fraction with a 12 in the denominator. So what we're going to do is multiply by 4/4, and that will give us 4/12. And we do something similar for the 1/4. So we're going to multiply that by 3/3 to get 3/12. Now you can see that we have 12 in the denominator for both of our fractions, and that's going to make them easier to add together. Because once they have the same denominator, all you have to do to solve is to add the two numbers in the numerator together. And then that would give you your final answer down below. So just remember when you are converting, when you're converting these fractions into an equivalent fraction, all you're doing is multiplying by 1. And that is changing the appearance of the fraction without changing the value. And to figure out what number you are multiplying by, all you have to do is find the lowest common denominator and figure out what number you need to multiply that fraction by or that denominator by in order to get that lowest common denominator. So in order to get this 3 to become a 12, we need to multiply it by 4. And in order to keep the value the same, we need to make sure we also multiply the numerator by 4 so that we're multiplying by 1. So what we do to the bottom, we must do to the top so that we keep the value the same. Same for this. Sorry if I'm a broken record, but in order to get this 4 to become a 12 so that we can add them together, we need to multiply by 3. And if we're multiplying the bottom by 3, we also need to multiply the top by 3 so that the value stays the same, so that we're multiplying by 1, right? So I'm going to go over a few practice problems with you so that this can click a little bit better. So let's do the first one. So 50 over 90 minus 20 over 90. So the denominators are already the same. So we can just subtract the numerators. So that's just going to be 50 minus 20 over 90. So 50 minus 20 is going to be 30, and that's 30 over 90. Notice we can reduce this further. They're both divisible by 10, so that gives us 3 over 9. And then the numerator and the denominator are both divisible by 3. So that would give us 1 over 3. For the second problem, we have 1 over 6 minus 3 over 2. So we can make the denominator here a 6 by multiplying it by 3. So if we multiply this by 3, it becomes 6. But we just changed the value of the fraction because we just multiplied this entire fraction by 1/3. So to keep the value the same, what we do to the bottom, we must also do to the top. So notice now it's like we're multiplying by 1. So that changes the appearance without changing the value. So now we have 1 over 6 minus, and we can rewrite this as 3 times 3, which is 9, over 2 times 3 is 6. So 1 over 6 minus 9 over 6. So 1 minus 9 is going to be negative 8. This is going to be over 6. And notice how we can reduce this further because they're both even numbers. So we can continue to divide by 2. So 8 divided by 2 is going to be 4, and 6 divided by 2 is going to be 3. And we have our negative sign there from before. So our answer is going to be negative 4 over 3. So for this next problem, we have 4 over 6 plus 9 over 10. Right away, we can tell that the 4 over 6 can be reduced by dividing the numerator and the denominator by 2. So that's going to give us 2 over 3. So now we have 2 over 3 plus 9 over 10. So when I think of the multiples of 10, I have 10, 20, 30, 40. And right away, I notice that 30 is a multiple of 3. It's 3 times 10. So what I can do is multiply the numerator and the denominator by 10 to give us 30, and multiply the numerator and denominator by 3 to give us 30. So notice how we have 30 in both denominators now. That's going to make this easier to add. So that's going to be equal to 2 times 10, so 20 over 30 plus 9 times 3, so that's going to be 27 over 30. And then that's going to be equal to 47 over 30. And that's how you do that. And for the final question, we have 6 over 7 plus 3 over 5. So a quick way to just get a common denominator without checking if it's the lowest is just multiplying by the opposing denominator. So we're multiplying by 5 over 5, and on the other one we're multiplying by 7 over 7. And that just makes things easier. But you might have to do some reduction later if you didn't get the lowest common denominator the first time, but that's okay. So we have 6 times 5, which is going to be 30, over 7 times 5, which is 35, and plus 3 times 7, so that's 21 over 35. And then that's going to give us 51 over 35. So the last thing I'm going to talk about in this video is converting between improper and mixed number fractions. So let's just get a few definitions out of the way. So a proper fraction is where the numerator is less than the denominator. So that would be like 1/2, for example. An improper fraction is where the numerator is greater than the denominator. So 3 over 2, for example. And a mixed number fraction is where you have a whole number accompanied by some sort of proper fraction. So like 1.5. So a lot of the time, if we have a mixed number, we'd like to convert it into an improper fraction because that makes things like multiplication, division, addition, subtraction easier. And then if you want, you can convert it back into a mixed fraction later. So that's why we're doing this. So the first step in converting a mixed fraction into an improper fraction is keeping the same denominator. So if we have 1.5, we're going to keep the denominator as a 2. Now to get the numerator, all you have to do is multiply the denominator by the whole number, then add the numerator. So we're going to do 2 times 1, so the denominator times the whole number, and then we're going to add 1. So 2 times 1 is 2, plus 1 is 3. And we're just going to put that on top here. And so we have 3 over 2. And it's that simple. So let's just do some practice problems here. So for our first practice problem, we have 2 and 11 over 12. So to convert that into an improper fraction, what we're going to do is keep the denominator the same. And then we're going to do 12 times 2 plus 11. So 12 times 2 is 24, plus 11 is going to be 35. And the reason I was able to do that so fast is because I know 11 is 1 less than 12. So this is kind of the same as doing 12 times 2 and then adding another 12. So 12 times 3, which is 36, and then subtracting 1 because 11 is 1 less than 12, so 35. And for the second question, I have 1 and 7 over 8. So I'm going to keep the denominator the same. I'm going to do 8 times 1 plus 7. So 8 times 1 is 8, plus 7 is 15. And the reason I got 15 so fast is because I know 8 times 1 is 8, plus another 8 would be 16, because 8 times 2 is 16. And I have my multiplication tables memorized. And since 7 is 1 less than 8, I'm able to quickly say it's the same as 8 times 2 minus 1, so 15 over 8. Now for the next one, we have 2 and 5 over 6. So I'm going to keep the denominator the same. And I'm going to do 6 times 2, which is 12, plus 5 is going to be 17. And that's because 6 times 3 is 18, minus 1 is 17. And so I get 17 over 6. And for this last one, I have 4 and 1/3. So that's going to be 4 times 3 is 12, plus 1 is going to be 13. So 13 over 3. Now going from improper to mixed is a bit more difficult, but it's not too bad. So all you're going to do is keep the denominator the same. Then you're going to divide the numerator by the denominator to get a whole number and a decimal. So this decimal represents your remainder. So this becomes the whole number in your mixed number fraction. So 14 divided by 3 is equal to 4.6. So that 4 is going to be that whole number. And you're going to keep the 3 as the denominator. And for the third step, you're going to multiply the decimal, so that 0.6 that's remaining, by the denominator to get a whole number. So that 0.66666 into infinity times 3 is going to equal 2. So that's your whole number that's going to be in the numerator. So that's going to become the numerator of the mixed number fraction. So that's how we get 14 over 3 equals 4 and 2/3. And you can double check this by quickly converting it back into an improper fraction by doing 3 times 4 is 12, plus 2 is 14 over 3. Yeah, and if you're good with doing these simple problems in your head, like a simple division of 14 over 3. Like if you can tell immediately that it goes into, or 3 goes into 14 4 times with a remainder of 2, then you can skip this third step. You can just do 4 and 2/3, where 4 is the whole number and 2 is the remainder, and 3 is the same denominator. But if you're dealing with larger numbers, that gets increasingly difficult. And so that's why I thought I would show it this way with the decimal, and then just multiplying that by the denominator to get the numerator that way. So if you're having trouble, just take a screenshot of these steps and do some practice problems on your own. But I'm going to go through a few practice problems with you anyways. So for the first problem, we have 29 over 3. So I know that 3 goes into 29 9 times. For 9 times 3 is 27. And then I have a remainder of 2, so it would be 9 and 2/3. But if you can't do that in your head, all you have to do is punch this into your calculator and you'll get 9.66666666. So once you get 9.666666, I can just represent that with this straight horizontal line over the 6, and that just means that number repeats indefinitely. So to convert this into a mixed number, remember I said you keep your denominator the same, so it's going to be 3. Your whole number is going to be this 9 here. And to get the numerator, we're just going to multiply this decimal by whatever our denominator is. So 0.66666 times 3 is going to be 2. So that's how we get 9 and 2/3. For the second problem, we have 18 divided by 6. That one's very simple because, 6, 12, 18. So 6 times 3 is 18. So therefore, 18 divided by 6 is 3. This next problem's a bit more difficult. So we have 53 divided by 2. One way you could do this in your head is simply by doing is equal to 52 divided by 2 plus 1/2, right? Because if you remember, when you add, you have if you have the same denominator, you can just add the numerator, so that would be the same. And we know that 50 divided by 2 is 25, and so 52 divided by 2 would just be 26. So that be 26.5. But if you punch that into your calculator, you'll just get 26.5. And then to convert that into a mixed number, you would just keep the denominator the same, so the 2. You would keep the 26 here, so the whole number. And then the 0.5, you would just multiply that by whatever your denominator is. So 2 and 0.5 times 2 is 1. So that's how you could get that way. And for our last question, we have 100 divided by 7. So if you punch 100 divided by 7 into your calculator, you're going to get some approximate number of 14.28571. And to convert this into a mixed number, all you're going to do is keep the denominator the same, so 7. You're going to keep your whole number as 14. And to get this numerator portion, if you want to keep it as accurate as possible in your calculator, once you do the 100 divided by 7, you get this number. All you have to do is subtract that whole number, and then your calculator is going to leave you with 0 point whatever. And then all you have to do is take that answer and multiply that by 7, or by your denominator. And that's going to give you this value here. And so that's going to be 2. So your answer is going to be 14 and 2 over 7. So I just realized I lied when I said converting between mixed fractions and improper fractions was going to be the last thing I talk about, because I just remembered about fractions raised to a power. So a fraction raised to a power is very easy. It's simply the numerator to the power divided by the denominator to that same power. So for example, if we have 1/2 raised to the power of 3, that would simply be the same thing as 1/2 times 1/2 times 1/2, which would be 1 times 1 times 1 over 2 times 2 times 2. So 1 to the power of 3 over 2 to the power of 3, which is just 1 over 8. However, you have to be careful if the base is negative. So the base is the thing that is being raised to a certain power. So if that base is negative, the product will be negative if the power is odd, or positive if the power is even. And I'm going to show you why just now. So for example, if we have negative 1/2 to the power of 2, that's the same thing as saying negative 1/2 times negative 1/2. And if we multiply two negative numbers together, we get a positive number. So we end up with 1 to the power of 2 over 2 to the power of 2. And that's going to give us 1 over 4. However, if we have negative 1/2 to the power of 3, that's the same thing as negative 1/2 times negative 1/2 times negative 1/2. So these two, when multiplied together, give us a positive value. And when we multiply this positive value by this negative value, we're going to get a negative value. So that is why our product is going to be negative. So we end up with negative 1 to the power of 3 over 2 to the power of 3. One last thing I want to draw your attention to is that this is not the same as this. And I know a lot of the times some people get confused with brackets. So I'm just going to explain this very quickly. So negative 1/2 to the power of 2, that is the same thing as saying negative 1/2 times negative 1/2. And that is a negative number times a negative number, so a positive number, and it's going to be 1/2 times 1/2, so 1 over 4. So it's going to be positive 1 over 4. If we look at this is the same thing as saying negative, so minus 1, times 1/2 times 1/2, so 1/2 times 1/2, because this power is applied to this base, not applied to this negative sign. So that's going to be the same thing as saying 1/2 times 1/2, so 1/4, and then multiplying that by negative 1, so negative 1/4. So you need to be careful about your use of brackets. And that's all. So thank you for watching. I really appreciate it.